Okay, for today, our goal is to teach you about function notation. All right, so let's get right to it. We have a lot to do today. If you put in $2 in a pop machine, do you always get the same kind of pop? No. Is a pop machine a function? All right, I want you to think this through for a second. In a function, when you put in a number, like when you put in 2 into the function, here's where 2 is. Those are the x's, these are the y's. These are the inputs. The x's are the inputs. So if I put in a 2, then the output is the y. Output. One more thing you should know. Do you know which of these two is considered f of x? F of x is either x or it's y. Which one do you think f of x is? Y. Very good. F of x is the same thing as y, which means it's the output. And last but not least, there's something called domain and range. X, those are the domain. And these are the range. Did you get that I just gave you 4 different names for the y? It can be called y, it can be called f of x, it can be called the output, or it can be called the range. And there's ones that go together. Like, for instance, the x goes with the y. And the input goes with output. Those even sound alike, right? And then there's domain goes with range. Have you heard of domain and range before? Maybe you didn't know what they were. Domain's just the x numbers, the inputs. And the range is the y numbers. And the last thing, besides domain and range, there's independent and dependent. Which ones are which? Where does time usually go, on the x or the y? Time usually goes down here. That's a hint. Do you think time ever depends on anything? No, time is independent. So the bottom one down here, these are the independent things. And these are the dependent things. The ultimate independent thing is time, and the ultimate dependent thing is money. I'll give you an example. How much does a meal cost? It depends, right? Can you get enough food to keep you alive for like $1? You might not think so, but you can. I'll give you an example. You can buy white rice, which will keep you alive. Okay, it won't make you healthy, but it'll keep you alive. You can eat white rice for a long time. A lot of people survive on worse than that. But anyway, you can get white rice, and it could cost you less than $1. Okay, I'm not saying you're eating well. I'm not saying you're eating healthy, but you could eat and survive on $1. I'll give you an example. One of the reasons why I can prove that: half the world lives on $2 a day per person. So in other words, if they have a family of 4, it might be 4 times 2 is $8, but that's like all they have, $8 for the day, and they feed everybody, and that's all their money. That's not just for food, that's for everything: food, clothes, anything you want for shelter, any tools they need. They survive on $2 a day or less, half the world. So yes, you can live on $1 a day of food, but how much is a meal? It totally depends. Depends on if you're getting it like at Cub on the super cheap sale, or if you're getting it at a really nice restaurant. Even a really nice restaurant can be like, noodles isn't that bad, and you can eat at Noodles for like $8. But if you want to talk a really nice restaurant, it can cost you like $100. There's restaurants where it costs like $100 per person. Even at Disney, is it World or Land that's in Florida? Disney World. At Disney World, there's a restaurant where you can eat, and it's about $100 per person at Disney World. And I know it's expensive there, but that's really expensive, right? It's good food. You can get like lobster and steak, and steak and lobster or whatever you want, but it's super expensive. All right, so how much is a meal? Totally depends. My point: dependent things are here. They're on the y-axis. All right, So I just taught you a bunch of little words, but words are powerful, and you need to know them. So I want to just make sure you picked up all that. So I want you to, in your notes, find a blank spot. Maybe you have to add a page or whatever. All right, I'm going to go to the end where I have some white space over here. And I'm going to ask you, don't put it right where you have your notes because I want to test you now to see if that's stuck. Would you please label this first with X and Y? That's pretty easy. Did you put X here and Y there? All right, now if you always say them in order, and I'll try to always say them in order for you, then it's not too hard to keep the pattern going, right? How about domain? Where does that go? Right by the X. Good. And what goes with that? Range, okay. How about what word should I say first between dependent and independent? Which one should I say first? Independent, because that goes on the X. And then which one goes on the Y for that? Dependent, all right. You should be writing these down because otherwise you won't remember. And then the last step is f of x. Where does that one go? Y. There isn't anything comparable on x. It's kind of nice in a way. You don't have to remember a different thing for that. But f of x is just like y. All right. Next thing. Let's say I drew a little graph on here. Do you remember the test that tells whether or not that's a function? Do you think that green one is a function or not? If you know the test, you can look at it and go, yeah, that's a function. What's the test again? Yeah, I heard somebody say the pencil test. Well, it's called the vertical line test. All right, so I take a vertical line like this, like if you held a pencil over it, and if it would ever touch the green line twice at once, then it would have failed. This one passes the vertical line test, so it's a function. Imagine for a moment that I drew it like this. Do you get that it would pass in here, and as soon as it gets there, boop, doesn't pass anymore. Sorry, that was a little loud. Why? Because it touches twice. Let me say it a different way. Do you get that the X input might have been 8 right here, and it had 2 outputs, like it might have been 6 and it might have been 8 on the Y? Do you get, I'm saying one input had 2 outputs? All right, so that's how you can tell if something's a function. If you put in an input, it better only have one output. All right, next, take a look at these. These are kind of your typical function problems that you're going to do today. It says f of x is 2x plus 5 and then x minus 3. If I was going to say, where's y in all this? I don't see y. F of x is the y. They could have written y right here. Now, there are some advantages to saying f of x. It allows me to have multiple functions. Do you get, if I just said y equals this, and y equals 6x plus 7, and y equals x over 4, do you get that they're all called y? And that's kind of confusing. So with function notation, we can call one of them f of x. And what do you think we can call that one? G of x. What do you think we can call this other guy over here? P of x. You can make up any letter you want. Do you get the idea that calling them different letters can make it clear they're different functions? All right. Last, if I just had a y here and I said, I want you to stick in 2, there's no way to say that with a y. But if I'm saying, I want you to stick in 2 in this function, you can say f of 2. Do you get what I'm saying? If it was just a y, I wouldn't be able to do that. But if I say f of 2, do you get that just means stick a 2 in? Where? In the variable. So that's 2 times 2 is 4 plus 5 is 9. Over 2 minus 3 is negative 1. Negative 9. So f of 2 is negative 9. I think you can do that, can't you? Let's see. Would you please put in f of 8? Stick in. Really, by doing this, I'm saying stick in an 8. So you stick in an 8 here, and you stick in an 8 here and here. Remember, that means 2 times the 8, so it's 16 plus 5, 21 over 8 minus 3 is 5, 21 fifths. Raise your hand if you had 21 fifths. Awesome. Okay, I think you get sticking in a number. How about sticking in a negative number? Well, it's no big deal. You just stick in a -7 into everything. But let me make sure you get what this means here. Do you get that 8 for the x gave us 21 fifths for the y? I wish that was a nicer number like 7. All right. Let's try one of the other ones. I bet one of the other ones works out nice. So let's stick in -7 and see what you get. Go ahead. Let's see if we get a nicer answer. Like just a nice clean whole number. What are those things called? Except they're whole numbers is what you used in elementary school. We use something like it, except they can be negative, so they're called integers. All right. So your answer, let's try and find one of these that comes out to be an integer. When you stick in -7, does it work out nice? -14 plus 5 makes what? -9 over -7 minus 3, -10, 9/10. Dang. How about this, though? The negatives cancel, and it is 0.9, right? Isn't 9/10 the same as 0.9? Okay. So it's kind of clean. It's almost 1. 0.9 is almost 1, but it's not an integer, but it's clean enough that I can give my example here. We stuck in -7. Here's the thing that's kind of cool. A lot of people never connected before. If that's x and that's y, then that's a point on the graph. F of -7 equals 0.9 means that -7 comma 0.9, which is pretty much 1, is on the graph. -7 comma 0.9, which is pretty much up 1, is on your graph. It's a point. So as soon as I want you to be able to do this from now on, if I say that, you should be able to go, oh, so you're saying x is 3 and y is 6. Get what I'm saying? The x number goes here, right? And f of that number is the y number, so this is the x and this is the y. So it's a point. As soon as I say f of 3 is 6, that's a point. As soon as I say f of 2 is 12, that's a point. And the point is what comma what? 2 comma 12. Do you get how we just had a test where we gave you 2 points and you're supposed to find the equation? Do you get how the ACT might say this? F of 4 is 7, and f of -3 is 8. Write an equation for the line that goes through them. It seems really complicated, unless you realize, didn't they just give you 2 points? And then it's just like our last test. You have 2 points, and you can stick them in that little formula, and you can get the equation. What's the point for this one again? 4 comma 7. And what's the point for this one? 3 comma 8. Awesome. Now you got 2 points, and you could get an equation for it. You get the slope, and then you stick it into that y minus y sub 1 equation. All right. Some of you have that totally down. The average on the test was about an A minus, which is awesome. You're going to get your test back later today. And if you didn't do that, awesome. Averages are kind of like this, though. They can be like you have a bucket of cold water, really ice cold water. Have you ever had to ice something like your foot or your arm or something? It's like kind of painful to put your hand in it, right? You could have a bucket of ice cold water and a bucket of really hot water, like scalding hot water. And then you step into the ice cold one and you step into the super hot one, and on average, you're just right. See what I mean? It doesn't really work that way, right? Because on average, you guys had an A minus. Does that mean everybody had an A minus? No. A lot of you guys had awesome scores, and some people had there was a D. All right. So if you had a really low score, what do? Do you say, I give up? I'm getting out of this class. This is too hard. It is an option. You can say that if you want to. Okay. You have until the 28th. But what I encourage you to do is to say, I should just retake that thing. I should study for it and get this down. Because no matter which math class you take this year, you want to know your algebra. Okay, and that was algebra review, and very good stuff for the ACTs too. So if you didn't do so hot, you need to do corrections. I have a sheet for that. And you come in the morning sometime. What mornings am I available? Mondays and Wednesday during Mass, Thursday. I'm going to write that on the board up over here, and I hope it stays for a while. Right in this room. Monday, 7:05. Wednesday, Mass, and Thursday, 7:05. That's when you can get help from server. Okay? I'm here. You want to do a retake? That's when you see me. We don't do that during class. We got other things to do during class. Okay. Cool. We've almost finished. Now, I told you there was one thing at the end that was kind of hard. All right, so let's get to this page, this kind of pinkish page. All right, f of x is this, and g of x is that. They're just defining what two different functions are. If they say in the problem to use the f function, well, then you use the one I circled in black. If they say to use the g function, you use the one I circled in green. That's not scary yet. When they say find x when f of x is 21, a lot of people have trouble with that kind. All right. First of all, a lot of people by accident think they just said that x was 21. Do you get that that is not saying that x is 21? What is it saying? Y is 21. So where do you go stick that? Well, first of all, you got to make sure you're in the right function. We're not doing the g function right now. We're doing the f function. So I stick the 21 here. Do you get? Then you could solve it and figure out what f is. It's not that hard. Go ahead, do it. Figure out what x must be. If y is 21, you put it here, and that's a nice simple equation, a little two-stepper. Boom, boom. If you don't know how to do that, yeah, this class might be too hard. You got to know how to do two-step equations. Pause for a second. All the silence after you talked a bunch, which was great. Now the silence tells me you probably got this. So I'm going to put the 14 right there, and then I'm going to subtract 5 from both sides, and I get 9 equals x squared. Ooh, cool, x equals 3. Who is smarter than that? Yes? Okay. Yes? Ah, it's absolute value, so the answer isn't just 3. When you square root both sides, some of you already forgot. Don't you have to raise your hand because it's almost all of you. You forgot that this is absolute value of x is 3, and therefore there's two answers, 3 and negative 3. But let's not complicate it quite yet. We'll just go with the 3 thing for a minute. I think most of you said 3, right? Raise your hand if you thought it was 3. Okay, that's normal. Some people are extra smart and they realize it's actually 3 and negative 3. Okay, but now what do I do with that 3? You just figured out that x is 3. Do you get that that goes here? That x is 3? And you've answered their question. And what have you found? You found a point. Where is the point at? 3, 14. Okay. All right, now, this next part takes extra smart people. Pay attention. Okay. It's not impossible, but it is more challenging. All right. If I'm going to find m, that means at the end I want to know what m is. But what the heck is m? It's in there, and it's got another thing with it? That's really weird. All right, so think of it this way. Ask yourself, what do you know? Do you know what x is? Well, x is like m minus 2. What's another thing that you know and might be more helpful? Yes? No, m minus 2 isn't 21. That's important to know. It's not that is not equal to that. But this is the spot where x normally is, right? What's this? That's the y. Which function am I dealing with? G or f? So I'm in this function. And would you agree that y is 21? What's y again? F of x. So you put a 21 here. Didn't we just do that a second ago? Yeah, and what did it come out to again? 3. So this is the important part. You've solved this now, and you now know x equals 3. Do you get this as the x part? So let's see if you can get this. They gave us that y was 21. We stuck it in. We figured out that x is 3. Then would you agree with this statement? F of 3 comes out to 21. Do you get what I just did there? Because we figured out x was 3 and y was 21. If you write them right above each other like this, some of you are going to understand this. When I stuck in 3, I got 21, right? Stuck in 3, I get 21, right? Then these two have to be equal. Since those are equal, these have to be equal, and I already know somebody knows m. Yes? M must be 5. Think about it. 5 minus 2 is the same as 3. M must be 5. I'm going to give you another one. Let's say I said I figured out that f of 5 was 10. And then they're giving me f of y minus 12 is equal to 10. Well, logically, if this is equal to that, then that must be equal to that. And what would y have to be? 17. So that 17 minus 12 would equal 5. All right. I'm going to give you one more. This one. Try to solve it right now. I'm guessing only half the class can figure this out, and that's okay. You just need to understand it when we do it on the next test. This is the first day of the new unit. I don't expect you to be a master yet. First question, did they give you x? No. What did they give you? Y. Y is equal to what? 14. So you go stick it in the right function. So if we're talking about g, gotta be this one. That's 14. Hey, we already did that one. What did it come out to? F was equal to 3 and technically negative 3. Let's just stick with the 3 for now. Otherwise we'd just do the problem twice. But if it's really equal to 3, did anybody smart write g of 3 is 14? That would have been smart. So now that I've got that, a child of age 8 can do that. What's A got to be then? A must be 2. Yes?
So, like, because the 14 equals x squared plus 5, because that also equals negative 3, wouldn't you also have to give negative 3?
Yep. I'm doing this only part way because it's hard enough as it is. But you're right that technically there's 2 problems. And one of them is g of negative 3 also equals 14. So then a plus 1 has to also equal negative 3. But this is blowing enough people's minds as it is. I decided not to try to do that too. All right. All right. See this one? That's your final test. See if you can figure it out. Don't expect you to be a master yet. Try it. Try to get one of these. Did you do it already? Yeah. Oh, dang it. I thought we had, okay. Okay, so you probably can do that one. All right, I'm going to tweak it just a little bit. All right. That's 29 now. F of m minus 2 equals 29. If you're lost on this, start by saying y is 29. If that's 29, what did you figure out that x had to be? X must equal 5. Then you had to go f of 5 is 29. And then from there, you'll see it. I hope. What does M have to be? M must be 7. How many of you knew M was 7? Okay. If you never got that, it's okay. You'll learn it eventually. Right now, your subconscious is processing it. And you'll be actually working on it for the next several days. Your subconscious is much more powerful than your conscious. It can handle multiple problems at the same time and process them and think about them. So, all right. So now I need to give you some time for your first 20. When you're done with the first 20, your homework, it's a fairly short worksheet. I'm not having you skip any of them. Do the whole worksheet. It really is pretty short. Okay? So that's due Monday. There's a worksheet in today's file. Due Monday. All right. So here comes the first 20. I am not expecting perfect papers yet. This one does not go in the 90% or the, what is this class? Yeah, this doesn't go in the 90, this goes in the 10%. So it goes in, but only as a homework assignment. Please keep them upside down, my bad, until everybody, no calculators are allowed. Keep them upside down so everybody has the same amount of time. Oh yeah, that's all I have for the video for today.